Welcome, everyone. My name is Jana Foster. I'm the Engagement Manager for Maricus. Thank you for attending today's webinar. Just really briefly, I'm going to pull up the agenda for today's webinar. We're going to give a brief introduction of Maricus, and then Tina Sepapor is going to go over the regional overview for the Water Level Waves and Webcams network. And then we have Dr. Tim Canty, who will be doing a focus on the Maryland WWW network and the work with HydroNet. And then we have a student spotlight, Ava Pushing, and she's going to be doing showing off the HydroNet dashboard that she's been working on. And then Sherry Schwartz with Tetra Tech is going to be doing a demonstration and gathering some feedback on our OceansMap Insights. I am going to start with giving a brief introduction to Maricus. So Maricus is a nonprofit organization and one of 11 regional associations that make up the U.S. Integrated Ocean Observing System, also known as IOOS. We serve the Mid-Atlantic region, covering 10 states from Cape Cod, Massachusetts to Cape Hatteras, North Carolina. The region includes 5 major estuaries, like the Chesapeake Bay, and supports a population of over 78 million people. The Mid-Atlantic is rich in ocean and coastal data, and Maricus makes that data available to be turned into usable information that supports safe navigation, emergency response, environmental health, and resource management, and economic planning. We collect and serve our own near real-time observing data, while also integrating data from state and local agencies, universities, and other partners. These community and institutional collaborations are essential to understanding and responding to the unique needs of the Mid-Atlantic. All Maricus data is federally funded and certified, meeting rigorous standards that ensure the quality and reliability required of high-level decision-making at local, state, and national levels. Our suite of tools, including our OceansMap data portal, is robust, user-friendly, and highly customizable. Later in the webinar, Sherry from Tetra Tech will demonstrate how some of these features are being tailored to meet specific needs across the region. And then Maricus has 5 stakeholder-defined focus areas, including coastal hazards, maritime safety and commerce, fisheries and natural resources, water quality, and energy. And now I'm going to be turning it over to Tina, our water level manager, to go over an overview of the regional project.
Thanks, Jana. Let me just go ahead. Can you see my screen okay? Good. All right, awesome. Sweet. Well, good morning, everyone. My name is Tina Sepapor, and I am the Water Level Project Manager here at Maricus. I appreciate everyone being here today, spending your morning with us. So before we get into the Maryland-specific work, I kind of wanted to give you a quick overview of the broader regional efforts that's going on here in the Mid-Atlantic. So to start off, coastal communities in the Mid-Atlantic are facing more frequent and severe flooding. So this can be anything from sunny day tidal flooding to storm surge and compound events, which is getting harder for local officials and planners to respond to effectively. And one of the things we hear over and over again is that we need better real-time data and more collaboration across states. So with this project, we're making that happen through sensor deployments and hydrodynamic modeling. Oops. There we go. So we call this the Wave, Water Level, and Webcams project, or the 3 Ws for short. So while this is part of a broader national effort led by IOOS, so they were highlighting the work here happening in the Mid-Atlantic. This project is a collaborative effort across 5 states supported by the Inflation Reduction Act that's helping coastal communities access the data they need to better prepare for flooding and build long-term readiness. This effort includes deploying low-cost water level sensors, wave buoys, ADCPs, webcams, and building hydrodynamic models to better track and forecast coastal flooding. The data we collect feeds directly into tools used by emergency managers and planners, which helps communities better prepare for things like storm surge, sunny day flooding, and wave impacts. And one of our main goals is to not only keep this data local, but we're working to align it with national standards so it can be used in federal platforms like co-ops and eventually feed into NOAA and National Weather Service tools. Ultimately, these efforts improve real-time awareness and support long-term resilience planning across the region. So we've been working closely with the Weather Forecast Office to improve local modeling and forecasts by sharing the data we're collecting through this network. But this isn't just about pushing out the data. A big part of this is building that two-way conversations with communities. So we want to hear from you and know what kind of data would be most useful in your day-to-day work or planning. And this first year is really about listening and learning. So where are the gaps? What's missing that would help you plan or respond to flooding better? We're also making sure that we include a wide range of voices. We're doing this by connecting with tribal, local, and regional partners because at the end of the day, every community has different needs and priorities. We have a customizable data platform called OceansMap that Sherry will talk more about shortly. But we want to know what would you like to see on it and what would be most useful to you and your team. Again, this is a collaborative project, and the input we get from you directly shapes the tools that we're building that would be most helpful, that would be helpful for you and your communities. So we are partnering with the University of Delaware, University of Maryland, Stevens Institute of Technology, Monmouth University, and Virginia Institute of Marine Science to enhance monitoring across the Mid-Atlantic. And although each state is tailoring their approach to meet local needs, in the end, we're all kind of sharing the common goals, such as improving flood forecasting and early warning, supporting community readiness and adaptation, and integrating this data into national and regional tools like OceansMap. So now that I've kind of given you a bit of an overview, I'm going to briefly talk about what our other partners are doing in other states. So the first project is through the University of Delaware. This project is run by Dr. Jack Palayo and Dr. Alexandra Schuler. So the goal of their project is to assess local communities with coastal process understanding and provide real-time knowledge for data dashboard use and install a wave buoy network for offshore models and forecasts. So on the map, you can see those red dots. Those are going to be the proposed SOFAR buoy locations that would be giving us the hourly updates. We are also planning on putting out water level sensors, and the locations for those are still pending. So there is ongoing engagement to figure out where we want to put those. Next up is a partnership between Stevens Institute of Technology and Monmouth University. This is run by Dr. Philip Orton, Dr. Laura Kerr, and Dr. Tom Harrington. The goal of this project is to create a higher resolution shallow water barrier estuary model to improve water level predictions. So there has been regional planning in the state, but they're still dealing with a lot of flooding issues like nuisance flooding or the sunny day high tide flooding, especially in low-lying areas in the barrier islands. And what they're going to do is focus on data collection both over water, I'm sorry, in water and on land by using SOFAR buoy, ADCP, and water level sensors. They want to see if the SOFAR buoy works well in back bay areas that have shorter periods and smaller waves. And they will be working with communities to identify which locations are best suited for water level sensors to meet the community's needs. Along with this, they will be utilizing data collection apps like MyCoast, where they can collect photos with time and location stamps and see where flooding is happening. So this will help verify flooding close to the tide gauges or even an area where there isn't a tide gauge close by. And it can help verify their flood model, which they hope will help create more accurate forecasts using the Stevens Flood Advisory System. And last but not least, um, at the Virginia Institute of Marine Science, this project is led by Dr. Derek Loftus, and with this project, he's more focused on the southern Chesapeake Bay area, especially around Hampton Roads. They're looking at locations that are dealing with regular flooding, but usually don't have enough water level sensors in place to monitor it effectively. So a big focus is on supporting rural communities that fall between the more urban population centers. And these communities often don't have the resources to install or maintain sensors on their own. So this project is going to be a huge help to fill in those gaps. So every year they're going to be focused on different parts of the coast. So we have the Middle Peninsula, Hampton Roads, Eastern Shore, Northern Neck, and the James River. And they're going to be deploying two types of sensors. So you're going to have your water level sensors, and then they are also going to be collaborating with USGS in years 2 and 4, where they're going to deploy AI machine learning cameras that can estimate water levels by analyzing videos. So all of this data that they get is going to be fed into a tool called TideWatch, which is a 36-hour storm tide forecast model that helps validate and predict where flooding is likely to occur. And since some of these areas don't have sensors yet, they're also bringing in the community science side by encouraging people to report local flooding through mobile apps. This kind of input will help decide where those new sensors should go, especially in spots where both the model and residents confirm that flooding is happening. So they're planning on installing about 20 water level sensors across coastal Virginia over the next few years, and those exact locations are being prioritized based on flood risk, data gaps, and then the community input. So I appreciate you guys listening to me. To kind of wrap all of this up, this regional network of sensors combined with OceansMap is giving communities the tools they need to understand and respond to coastal changes. And we're really proud to support this work across the Mid-Atlantic and excited to see what happens in the next 5 years with this project. So I do have my information on there in case you guys would like to check out our website or want to send me an email or anything like that. And with that, I'll go ahead and pass things over to Dr. Tim Canty from the University of Maryland. Dr. Canty is an associate professor in the Department of Atmospheric and Oceanic Science, and he is also the director of the University System of Maryland's Marine Estuarine Environmental Sciences graduate program. So he brings experience from NASA's Jet Propulsion Lab and UCLA, and he is our leading he is the leading person for our water level project here in Maryland. So I will go ahead and pass it over to him.
Thanks, Tina. Just share my screen. Look okay? Okay, great. So thanks everybody, and thanks for this opportunity to speak with you about our current effort. I'm representing a team of people, Mike Maddox, Ava Pushnig is going to talk in a little bit, and Katie Lehman, who I think is also online. So we have a small but very dedicated group on this project. There's my contact information if you want to reach out to me, and I'll post that again later. We're also part of the University of Maryland Climate Resilience Network, which we'll get into that in a minute. So, why are we focusing on the Chesapeake Bay? Obviously, it's environmental issues that it's dealing with, but sometimes it's not a good motivator for people. So I'm also a faculty fellow in our business school. So you can also make the economic argument that the Chesapeake Bay contributes about $100 billion annually to the Mid-Atlantic region. And it's faced growing threats from sea level rise, inundation, salinization of fresh water. There's a whole laundry list of issues here. And the picture I'm showing is Crisfield, Maryland. We were down there last Friday, in fact. This photo is from Tony Laird. I've often talked to, if people haven't been to Crisfield, I tell them, well, Crisfield isn't so much on the bay, but often in the bay. And if you look down here, you can see it's a nice sunny day. There's no exceptional weather event going on. It's just a high tide, probably a king tide, but you can see how far that water is moving in to the city. And obviously, this is quite disruptive. We've talked to community members who tell us about, driving to the grocery store and getting a phone call that they're going to have to walk back because they can't drive, the water level's too high. This was a picture we took last Friday, and pointer here. You can see water on the side of the road. This is the bridge entrance to the Crisfield Hospital. This was just a normal high tide, and you can see the water has taken away about a third of the road. There's also an adult care facility, I think, over there by the hospital as well. So you can imagine how disruptive and potentially dangerous these frequent flood events are. We learned last week they have about 3 or 4 days off of school each year because of flood. They have more flood days than snow days. So this is a pressing problem all across the region, but Crisfield is, in like other places, kind of a canary in the coal mine of what's going on. So as I mentioned, we're part of the Climate Resilience Network. This is a program funded under the University of Maryland Grand Challenges program, which is created by President Pines and Provost Jennifer King Rice. This was an institutional grant with matching funds from different colleges that brings together the Earth System Science Interdisciplinary Center, Atmospheric Oceanic Science, Geology, Geography, and the Marine Estuarine Environmental Sciences graduate program. So in a sense, a lot of the earth sciences here at the University of Maryland campus. With the focus of our particular group is scientists serving communities, getting out of our offices and labs and getting into the communities and trying to find ways that we can help. So this project was long in planning and kind of a sister project to the Maryland Mesonet, which is building weather stations all over the state. Some of us started talking about, well, what other monitoring could the state benefit from? And we started, obviously, flooding was a big risk, so we started looking to this. We're building the Maryland HydroNet, which is a network of low-cost water level sensors. We're using the Hohonu sensors, which are great. They're just plug and play and relatively low cost. We want to provide information to local emergency managers. We're not going to put out alerts or emergency warnings. That's the job of the people on the ground, but we want to provide them accurate, up-to-date information. We want to track long-term water level changes in the region and assist communities in planning and flood adaptation and mitigation strategies. The questions we've been asked, is this needed if there are already tide gauges in the region? And this isn't driven by me as a scientist. Our community partners say, yeah, this is really important. The topography of the Chesapeake Bay is complex, and with changes in meteorology, this can lead to very localized flooding, and a couple of inches of difference in water could mean flooding or not. And what may impact one area 2 miles away from another could be very different. And so we need this kind of targeting of hotspots where the flooding is occurring. So we started with a pilot project in Annapolis and Charles counties. This is actually me getting to use power tools. I'm a modeler, so they don't let me out much. Phase 1 was kind of the western shore of the Chesapeake Bay. Phase 2 is moving into the eastern shore, and then phase 3 we want to get further into the coastal bays and inland, but prioritizing high flood risk communities that lack really monitoring infrastructure. We have a cluster of sites in Annapolis, and this is where we started. And the reason is Annapolis faces significant flooding. There's complex terrain right there, and we thought this was a good place to start. The picture on the right is our first deployment sensor. This is near Cobb Island, which the bridge to the island gets flooded, and they need to know whether the community needs to know whether paramedics need to be stationed on the island before the flooding occurs, so people on the island have access to medical help if needed. And it's a picture of myself and Mike and some of our partners with Charles County who help facilitate deployment there. So going back to Annapolis, one thing we're trying to do is help support Annapolis in their efforts in tackling the flooding of the city dock region. And this happens quite frequently. If you go to Annapolis, on any high tide day, that downtown area, the docks where the statues are, is frequently flooded. We often think of hurricanes, but it could just be another weather event driving this. And I'll have an example in a little bit. But nonetheless, Annapolis is investing, almost $90 million in making the downtown city docks and helping the business there become more flood resilient. Right next door, Naval Academy is spending about $40 million to repair seawalls and take other steps to limit flooding. So you have, let's just say, $100 million to cover a few hundred yards of an 11,000-mile coastline for the Chesapeake Bay. If you stretch out the Chesapeake Bay and the rivers and everything, it's 11,000 miles. So this is a good start, but there's a lot more coastline that we need to be concerned about, in my opinion, at least. So the blue sites here are sites that have been deployed and currently operating. The yellow sites are notional areas where we want to deploy to. We have been, pun intended, inundated by requests from inland communities. Obviously, flooding this year has been a big topic of discussion all across the country, but also in our region. And it's not just coastal flooding. Inland areas are getting flooding, and we're trying to find ways that we can support these organizations as well. Vital to our success is creating partnerships with community stakeholders. I can't just go in and start drilling holes in docks and putting sensors up and people will be okay with that. When we first started this project, someone asked, well, where do you want to put the sensors? I said, well, that's not up to me. That's up to you guys. You tell me where you need them. And so we had an unveiling event in downtown Annapolis on June 5th a year ago. We had a lot of representatives from the state, our university presidents and deans were there to really kind of kick this off, what we're trying to do, get our efforts out there and hopefully to build more partnerships across the region and to help find more partners. We do have now an annual in January stakeholder event. We'll be sending out information about that. Basically, just sit down and talk to the people and what do you need? How can we help you? These are some of our partners, not all of them, but it's when you go out to organizations and we say, hey, can we put some water level sensors? They're skeptical and they say, well, how much is it going to cost us? And I say, it's not going to cost you anything. It's going to cost us, but it's up to me to keep finding the funding. And with that approach, we've been welcomed all over the state, and this has been really rewarding for me and I think for all the people in our group. Because we really do want to get out there to help our partners and help our communities. We live here. I live in Maryland, and these are restaurants I go to. These are communities I go to. I have a vested interest in protecting our communities. And so again, this isn't just a research project for someone to publish a paper and go to a conference and talk to all the other nerds about all the work we're doing. No, this is about getting into our communities. The science will come out of this. When we try to answer questions and how to help our communities, we can find where the limits of the science currently is. And then we go back to our science communities and say, hey, we're trying to help our communities, our cities, our counties, and we can't answer some of these questions. So we need more data, better data from the satellites, better models to answer these questions. We need more science. And so there's this nice feedback. It's challenging at times, but I'm air quality scientist and I work with the state. And so we find this all the time, opportunities to do science while also trying to address the needs of our communities and our neighborhoods. A case study on kind of the value I see of what we're trying to do here. This is downtown Annapolis. This is when the remains of Hurricane Debbie came through. So Hurricane Debbie hit down south in the Gulf, I believe, made its way up along the coast, well, inland. And what's interesting is a lot of hurricanes seem to be carrying more energy further inland, leading to flooding up in the Northeast in areas areas that do flood, but the amount of flooding we're seeing is a lot more than what we used to see, not just in Maryland, but all across the Northeast states. So this was when the remnants of Hurricane Debbie came through, and we did have a sensor installed. We did have our sensors installed here. So this is a map of winds. The greener the color, the faster the winds. If you can see this green dot here, this is Annapolis, and the winds here are coming from the southeast. This little spiral here to the southwest, that's the remains of Debbie. And this is as Debbie moved to the northeast. And you can see it's moved a little bit further north. The winds have shifted. Now they're coming from the southeast. And then as Debbie continued on its way, the winds shifted now to the southwest. So instead of coming from the bay, now across the land. So what was the impact in downtown Annapolis? Now the bottom panel here shows water level as measured by one of our sensors at the city dock. And we can see it got up to almost 4 feet, which is much higher than predicted. And during this time, when I was watching the monitors and watching water levels go up and up. And when you see that the low water level is almost higher than the previous high tide, you know you have to worry. And I was on campus at this time. We had numerous tornado warnings. In fact, campus was closed. I stayed here. But I was reaching out to some of our partners in Annapolis and Charles County. I said, are you guys keeping an eye on the water level sensors? Because this doesn't look good. And they said, oh yeah, we've been monitoring this. And you can see how high, a peak flood in the picture I showed you, what we're showing in that figure, this is what it actually looks like. So here's what real people are dealing with. Here's what the data looks like. Now, the black line up top is wind speed in miles per hour. And you can see as the water level was building up, winds were between 10 and 15 miles an hour. And the blue line is the wind direction. So it's coming from the east and southeast. When the storm passed further to the northeast, you can see the wind speed died down. And this is when the winds shifted now they're coming from the southwest. And then the water kind of sloshed back in the bay. Now, I have a close colleague from the business school, lives in Dorchester County on the eastern shore. And I contacted him. I said, Cliff, are you guys flooded out? He said, no, we're really high and dry out here. So this was a completely wind-driven event. Getting the water level data is great, but putting into context requires these other complementary observations like wind speed, wind direction, rainfall rate, rainfall amounts. So is this a weather-driven event? Is this a tidal event? If it's a weather-driven event, is it a severe storm like a hurricane? And we see there's flood warnings in the bay, especially down in Crisfield because of Hurricane Erin coming through. Is this a nor'easter that's coming through? Is this an upstream event and the water's flowing into the bay? So this is great data that we didn't have before, and we're always looking for complementary data to help explain what's going on. Another issue with flooding is our infrastructure, obviously, and bridges are a big thing, obviously, in Maryland. And when I first started talking about this and delving into this subject, we're talking about infrastructure, roads getting flooded out, bridges getting flooded out. And I started talking to a couple folks from the Coast Guard, and they said, well, yeah, this is all important. This is the Bay Bridge. They said, yes, it's important, obviously, to be able to get over the bridges, but if you're on a boat, you want to get under the bridges. And what do you do when the water level's going up? And this was one of these, I never thought of this. This just wasn't on my radar, so to speak. Water levels rising, that gap between the top of the water and the bottom of the bridge is shrinking. So how do you get under the bridges? This is the Bay Bridge. There's a lot of clearance here, but these container vessels, cruise ships are large. They're getting bigger. And if you have less clearance, it's potentially harder to get under these bridges. Now, these are the large bridges, but as we know in Maryland, our bridges don't float. And so if ground is subsiding, water levels going up, is it going to be harder to get under the bridges? And what about the smaller bridges, the local bridges to get to a marina, or some people park in their yards? What about all of that infrastructure? What's it going to cost to raise all our bridges? How do you prioritize? Also, as land subsiding, water's going up. What about getting into the Port of Baltimore? So container vessels are large, bridge clearance is shrinking, ports are going underwater. I've been to ports conferences before, and this is a global issue that people are talking about. So if you're going to relocate our ports, where do you relocate them to? Who do you move out of the way? What about train bridges, foot bridges, bike bridges? Again, small bridges in smaller communities, if they're not a swing bridge or a drawbridge, will you have to unmast or red light, green light? Like, oh, we need to get back to our home slip by this time because otherwise we're going to have to wait till low tide again. And this is a discussion I never thought of. And it just really made this even more important to me, because think of the costs of rebuilding all of our bridge infrastructure, and who's going to pay for that. So looking forward, this is another one of our sensors here. We're obviously looking to expand. We have a laundry list of sites we need to start putting up and working with our communities. Some things we're planning on and we're testing right now is automated notifications. Again, we're not going to put alerts out, but we want to give people the ability to sign up on a web page, tell us for whatever monitor, let's say it's Crisfield, when it reaches 1 or 1.5 feet above normal, or 1.5 feet just in general, it will send, we'll set up a system that will send that person a text saying, hey, we've hit that threshold. Do what you want with that, but be warned. And so this is to give emergency managers, at least, and community members, the ability, the ownership of this data, as opposed to having to drive around or wait for someone to call. The sensors will let them know. We want to ensure that the information is available and actionable, and Ava's going to talk in a second about this. We want to build some inundation modeling, to we just don't want to have data, but ingest this data into data assimilation models, combine it with regional climate models to really in high resolution inundation models that really have very high resolution topography to understand how local terrain, how local conditions will lead to flooding. So can we come up with threshold scenarios? Could we develop a web page where someone could type in a location, other data like soil moisture that's measured by the Mesonet, rainfall rates, current water levels, and to say, okay, based on this information and forecasted rainfall rates or forecasted wind speed, wind direction, we would say your risks of increases X%. Take that information and do what you need to do with it. Deploy swift water rescue resources, close roads, get people out of certain low-lying areas. Take the actions you need to take. We want to work with partners to find the resources to add other observations that are really relevant here. How much oxygen is in the water, the acidity of the water, the clarity of the water, temperature, water color. All of these things measure the health of the water, which has an economic impact on our communities and the health of our communities as well. Nitrogen, I'm an air quality scientist. What goes on in the water impacts the air. We know this for a fact. So we need to know, as we joke about surf turf above the earth, everything, what's going on, how that's impacting the environment, and the cascade effects on our communities and our economy. Land is sinking, so we want to measure that as well, and weather. So this holistic view, which we're calling right now the Maryland EnviroNet. We want this just kind of full-scale data of all aspects of the environment, because they're all pieces of the same puzzle. And so let's get this full picture of what's going on as best we can to get that information to the decision makers, to the emergency managers, to find out, to let them figure out how to allocate limited resources or how we can help find other resources. Like with watercolor, in fact, NASA just launched a new satellite called PACE that measures watercolor from space. Watercolor can be an indication of biological activity. Could we help provide ground information that could help with the satellite retrievals? I was at NASA for many years. I've been funded through NASA for a while. So even though with budget cuts that are going on, there's still science that we can work on. But other impacts of flooding that we're focusing on physical here, but talking about biological. So you have a flood event in Crisfield and that water flows in and then water flows back out again. But now you have standing water everywhere. And Mike Maddox is working with 2 summer students, and they did a study. They measured the water quality of some of these puddles, and birds poop in it, dogs poop in it, and I mean, it's gross, but now you get fecal bacteria in these puddles of water. You get mosquitoes in there. So there's potential health problems right there. But the next flood event comes in, floods, and all that stuff flows back out into the water. And now you're potentially risking the fisheries. So again, we focus on the primary impacts, the physical impacts of flooding, but there's always this cascade effect. Or if schools are closed, now does someone have to stay home from work because their children have to stay home? And so, it'd be great to do this kind of full front end to back end economic analysis of some of these events, or the risks to, say, community hospitals or community hotels, that sort of thing. The full impact of flood events and our changing environment. That's the target we're aiming at. Lofty, I know, I'm not naive about these things, but I think that's where we should be headed. And I think states in the Northeast, I think there's an opportunity. I was looking for opportunities where Northeast states could create, because we have these common problems, to create kind of a consortium of Northeast states to really focus on and share resources and knowledge. Just in the state of Maryland alone, we have resources in terms of environmental sciences that rival many countries. I'm not lying about this. And let's use these resources to build kind of regional leadership, working with organizations like Maricus and other acronym agencies on the air side of things. I think we have a lot of structures here. It's not like we have to build this from scratch. And I'm getting on my soapbox here, so I'll stop. But I really think we have an opportunity to build these very powerful consortia that can really address these issues that we're facing. If you're interested in learning more about the HydroNet or partnering with us, please reach out. We would love to work with you. Just here's my contact information. Call me, stop by anytime. I'm got coffee over here and hang out. We don't know what the problems are until people reach out to us. So we need our community partners. We are not charging folks for this. Maybe there'll come a day where we have to try to find other resources, but right now the whole focus is just getting into the communities and finding ways that we can help them based on what they tell us. We're not elbowing our way in saying we're going to solve all your problems. We're here to listen. What are the problems you're dealing with? How can we help? What resources do we have available to help? So please, please, please let us know. Very least, we'll put you on our mailing list. Maybe you can come join us for our stakeholder program. I said we'll be having in January. I'm going to leave it there and then pass it along to Ava, who's a student. We keep forgetting that she's not in my Department of Atmospheric and Oceanic Science. She's in the Information Science program, but we like her anyway. We tried to get her to switch majors, but we weren't fortunate enough for that. But she's doing some amazing work, things that I would love to be able to do, but I'm just not technologically savvy enough. But fortunately, I get to work with some amazing students who are. And so Ava's going to show off our preliminary dashboard. So Ava, take it away.
Thank you, Tim. Okay. All right, how's my screen? All right. Good morning, everyone. following Dr. Tim Canty's introduction to HydroNet, I'm Ava Pushnig, and my goal today is to walk you through our HydroNet dashboard, and you can explore it live at hydronet.umd.edu as I speak. So upon arriving at hydronet.umd.edu, you're greeted by our welcome page. This page provides an overview of the network, including our latest data snapshot. It's a quick glance at the current water levels across our stations. It also features our Contact Us section, where you can easily find information to connect us with the HydroNet team. From the welcome screen, you can then navigate over to our live data view, right on over here. Just gotta give it a second. This is the dynamic heart of the HydroNet. You'll immediately see a map feature displaying the real-time locations of our sensor stations. This map is interactive, so you can quickly use the drop-down to select individual stations right here. Or you can see them all at a glance, understanding their geographical spread and proximity to key areas across Maryland. Below the map, you'll find a time series widget. This powerful tool is designed for comparative analysis. It allows you to select and overlay data from multiple stations, enabling immediate visual comparison of water level trends across different locations over a user-defined period. This is incredibly valuable for identifying synchronized events, understanding localized flood impacts during specific events, and analyzing how water levels are changing over time at various points in our network. It provides dynamic high-resolution insights crucial for both real-time operation decision-making and preliminary scientific assessment. While the live data page offers immediate insights for the scientific community, the data download section is also vital. Navigating to this page provides an intuitive interface that empowers you to access the raw, high-resolution data directly. Here you can select specific HydroNet stations and define precise start and end date ranges and choose your preferred output types, typically CSV for easy integration into your analytic tools. This commitment to accessible open data is foundational to HydroNet's mission. Our minute-by-minute measurements are readily available for a multitude of scientific applications, such as improving existing hydrological models, conducting detailed studies on sea level rise, and facilitating seamless integration with other environmental datasets for interdisciplinary research. Additionally, under the activity page, you'll find media mentions, such as today, which we'll be working on getting more, our published articles, and photographic documentation of our field deployments and team efforts. Then we have some frequently asked questions sections, which provides detailed explanations about our sensors, maintenance protocols, and strict privacy safeguards. So this dashboard makes high-quality data available that is incredibly valuable for both science and real-world use. For researchers, our detailed minute-by-minute data is key to improving flood forecasting and understanding how sea level changes. For emergency managers and urban planners, it provides real-time information and insights to help them build stronger infrastructure and prepare for climate impacts. Ultimately, our goal is to make our data immediately actionable for a wide range of people. So we currently operate 12 stations and are actively working to expand our network driven by community needs and scientific priorities. We're committed to open science collaboration, making sure our data is a valuable resource for everyone. And I really encourage you to explore hydronet.umd.edu to see the dashboard's capabilities for yourself. We're always looking for new research partnerships and would love to hear your insights on how we can make this platform even better to support your analytical and operational needs. And there's always more to add, so please feel free to reach out using the contact information on the welcome page. And thank you guys so much.
Thank you so much, Ava. So we have about 10 minutes to take any questions that anyone might have. Feel free to either drop them in the chat or get off mute and ask them yourselves, whatever anyone is comfortable with. And I'm going to start off by asking Tina a quick question. Um, Tina, you mentioned that how this is a collaborative project across 5 states. Why is the regional collaboration so important here?
Probably would help if I unmuted myself. Yeah, so basically flooding doesn't stop at state borders. All the tide storms and surges that are happening are affecting the whole mid-Atlantic. So by working together, we can share lessons learned, avoid duplicating efforts, and build consistent data sets that are more useful for national tools like NOAA and the Weather Service. And it also helps us create a stronger regional voice so that local communities can access resources and expertise they may not have on their own.
Wonderful. Thank you very much. And then another question, Ava, how long have you been working on the dashboard and kind of how has the project been going for you?
I've been working on it most of the summer. It's been actually going really well. It's my first time building a dashboard through WordPress is what we've been using, and I've been really enjoying it. I've been learning a lot through it, but I'm excited to learn more with it.
Amazing. Thank you. Does anyone else have any additional questions at this time? All right. Well, Tim, do you have anything else that you would like to say?
No, I was just kind of joking to myself. It's like the first day of class. Semester's gonna be starting soon, and I always ask my students, any questions? I just afraid.
Well, great. Well, thank you all very much. We're going to move on to Sherry Schwartz from Tetra Tech to give a demo on our OceansMap Insights.
Great. Thank you, Jana. Hi, everyone. I am Sherry Schwartz, and I work at Tetra Tech Ocean Science. We are Maricous's data managers, and recently we've been working with the Maricous team to develop the OceansMap Insights, which we are continuously improving and which I'll be sharing with you today. So I'm going to go ahead and share my screen. All right. Let's see. You should be able to see a browser, the OceansMap Insights landing page. Awesome. So now the OceansMap Insights are actually pre-made permalinks to interactive map views and dashboards, and they were designed to provide quick and easy access to real-time data for a variety of scenarios or users. There are currently 22 different insights, and they're organized into these 5 categories shown at the top of the landing page on the Maricous website. So we'll go ahead and pick one to explore together. I thought an obvious good place to start would be the environmental conditions category. And I'm actually going to first explore this water temperature anomaly insight. I actually preloaded it this morning, so I'll just flip to that tab. So when you first open OceansMap, if you've never seen it before, usually it will load with a map and then some data visualizations, sometimes analyses like time series plots or other graphs preloaded. So like most map-based portals, you can navigate by clicking and dragging the map. You can zoom in or out with the scroll wheel on your mouse. You can use the trackpad on your laptop. We also have these plus and minus buttons down here on the right. And a zoom to box tool that allows you to just draw a box around an area of interest by clicking and dragging, and then it zooms right into that spot. There's also a few other tools up here in the top right that are useful for sharing your data or finding more information about it. So the share this view link is our permalinking tool. This is actually how we made the insights. And if you open it up, you can change any of these settings about what you want to preserve, create a URL, and then once that's created, you can copy it, bookmark it, save it to your desktop, email it to yourself or a colleague, and it's there forever. So you can always come back to it. You can also make a screenshot, generate an animation of your data actually changing over time. The Activate Hover tooltip allows you to hover your mouse over like a data layer and it will pop up with a quick view of what the data is in that spot most currently. You can measure distances. I showed you the zoom to box selection. And of course, there's our legend, which allows us to look at the color palettes and really understand how to interpret the data that we're seeing. Now, over on the left, we have several more tools that are really meant for diving into your data, exploring it, analyzing it more deeply. But first at the top, we have the data layers or the data catalog. So this is the full list of all the layers here. They are organized into categories and can be filtered. You can also search the catalog or filter to just show what's currently active on your map, or the map view, like what is available in your map's current view. There's also the virtual stations tool if you like to add virtual stations. You can use the weather window planning tool, generate validation statistics, create your own custom layers by adding shapes, lines, or points on the map. You can change up that base map if you don't like the view, if you want to change it a little bit. I'll come back to compare mode in just a moment because that is what this insight is looking at with this slider in the middle. We also have the full list of insights in a little toolbar here and a feedback form. So especially after today, if you have like questions, comments, or concerns that maybe you think about after the webinar, you can absolutely use this feedback form and submit some of that information to us. It comes as an email to me and the Maricus team, so we'll definitely get eyes on it and have someone take a look. Okay, so going back to compare mode, we'll kind of dive into this water temperature insight a little bit more. So I opened up this tool and it gives me some information about how my data is set on the map. So right here, I can see that my GOES sea surface temperature data is only on the left side of the map. And that's what this blue highlighted icon means. If it was on both sides of the map, this central square here would be highlighted blue. The anomaly layer is actually only on the right side of the map. And so to understand what these layers are telling me, we can see that the full rainbow color palette on the legend over here is for the sea surface temperature, but the anomaly data set only has two, like a kind of a binary color palette with blue on the left for negative values and red for positive values. And that's really telling us, if we see red, that means the temperature is warmer than average. And if we see blue, it's a little bit cooler than average. And so now that I'm kind of zoomed into like the Maryland area, I can actually just drag my slider to either direction and really take a look at what that temperature is looking like, seeing this orangish yellowy color and how that compares to the anomaly. If I really want to see even more details, I can click on a spot in the map and it will load those values for me at that location. It should do both of them, even though I'm only on one side of the map. And let's say you want to come back to this later, you could do that. There are a couple of steps I would take. First is add a virtual station. So once I've done that, it creates this little teardrop icon and adds a little virtual station label, but it also puts a badge over here in my actual virtual stations tool on the left. So clicking on that, I can see it's in here. I can delete it if I wanted to, or click on this little pencil icon, change the name, add a description. I can change the color if I want to. I can also change the location by dropping in different GPS coordinates or setting a different location on the map. Maybe I'll move it over here. Oops. All right. And that is the first step. The second step I'll do now, because now that I've made this change to my virtual station, I've added it to my map. If I go back to the Maricus landing page and click on that insight again, it's just going to load it the exact same way it was when we first started talking today. It won't have this virtual station here. So what I need to do is create that new permalink and then make sure I create it, copy it, bookmark it, save it, email it to myself, whatever I need to do to save it. That way I can come back to it later. And so that kind of showcases some of the real strengths of these insights because they are intended as kind of a starting point for specific use cases, specific users, and we'll kind of get into that in a little bit too. But you can then tailor them and customize them to your needs and come back to them later. So the second one that I want to look at today is a dashboard view. And this is the Navigation Chesapeake Channel dashboard. So this was designed to help people safely navigate through the Chesapeake by providing an in-depth understanding of conditions. So it's a great example of a particular user base that we would expect maybe using this information and how we can give them some just basic information right away that they can tailor and tweak to their needs. So right off the bat, we see some important observation metrics at the top. We do have air temperature, sea surface temperature, and salinity here in colored letters in the middle. But we also have some observation information in these tables. And there are 3 tables here. They're all scrollable, though they're pretty short. And so in the top one, we have current direction and speed, wind direction and speed, and wave direction and wave period. And what I like about these tables is that they give you a little bit more insight. Of course, we have our values here, but we also can see exactly where this information is coming from. So this is coming from a Chesapeake Bay buoy, so I know it's an observed data set, not a model. And it's that York Spit Station, which I think is this location right here. And that can be helpful, if you are going to pass this buoy on your route, but if you wanted to, you could change that location to maybe another buoy that's more relevant to the route you actually plan to take. We also see the valid time here, so we can see just how up to date this data is, and I think that's very useful. Before I do scroll down, I want to mention this map over here on the left is a kind of like a mini map widget. It's not the full Oceans Map widget within the dashboard, though there is an option for that, and I can show you that in a little bit. But this one is just a very simple kind of put some layers on the map and have a little display of the location and what you're looking at and talking about here. So I can open up the legend and we can see that we do have the Chesapeake Bay buoys, but also the CBOF's water level data in this color palette, so we can get a sense of what that water level looks like throughout the bay. Okay. So scrolling down, we do have a few rose plots here, and these are actually summarizing the past 2 days of observed data from that York Spit station. So the first one is the wind speed and direction. We also have wave height and direction here, and current speed and direction as well. And then we have some time series plots, and these are actually showing predicted data sets. So these are more from models like the Maricou CBEFs or NWPS to help give an idea of what conditions are expected to be as we move forward into the future. So we've got water level, currents, waves, and winds. So this is a good example if you were a boater and you wanted to use a lot of this information, maybe even like, using that York Spit Station data, but you might want to tweak the location of where these time series are pulling data from. So to edit a dashboard, the first thing you'll need to do is click the unlock button, and you'll see that gives us the opportunity. Now we can delete widgets if we wanted to. We can also just make them bigger, move them around. We can manipulate this however we want. Oops. Well, I won't worry about that. But we can also, what I want to show you is click the pencil icon, and that opens up our whole menu of settings. So now I can change just about anything I want. The parameter I'm looking at, the actual data set or the model that we're pulling up. We can change the offset range if we want to plan for specific dates, or maybe if we only want to see the next 24 hours of data. But this is also very useful here is this map. If you have a good GPS point that you want to put in with a lat and long for your route, you could do that. You can also just kind of click on the map wherever it makes the most sense for your needs. And then once you save the widget, it will reload. Once you're done, relock the dashboard, and then you can click the share this view to recreate your permalink. And once again, make sure you copy it, save it, email it to yourself, whatever you need to do. And you can come back to it later. All right. Our third insight that I want to show you is the East Coast storm tracking. This one's super interesting to look at today because we do have a storm out there, as you all know, Hurricane Erin. So there's a lot of information in here. It can be overwhelming. So let me open the legend. So what we see right off the top is the NHC tropical cyclone. So this is showing any active storms that the NHC is flagging. And we can see that it is this layer here that's showing us the entire trajectory of the storm, including where and when it became a Category 1 hurricane and how it progressed, and the predicted track as well. We also have global GFS winds, which are these barbs. So if I zoom in closer to the storm, we'll give that a second to reload, and those barbs will kind of show this really tight circle, and you can really see all those, the number of barbs showing the magnitude of the wind. We also have gliders on here, so those are these black tracks, which you can see we're headed out trying to get some information from the storm. We also have surge tide data, which I know is fully transparent. So this color overlay you're seeing is actually the wave height data. And that's why we've got this big dark red center of the storm and then kind of lightening as you go outward. So if you wanted to maybe are interested in the storm, interested in seeing how these models are doing compared to the actual observations that's being measured off the coast right now, you could absolutely do that. We do have a virtual station already preloaded here for Elizabeth City, North Carolina, but we can zoom in maybe a little bit more towards Maryland. Give it a second to load. And so what we'll do in order to understand how these predicted values are doing compared to observed or even other modeled values is use the validation table or the validation tool. And so once that's open, I pick my parameter. A good one for this might be wave height. You could also, winds would also be a good example. And now we need to pick a baseline. Like I mentioned, that could be another model, but if you wanted to use an observation station, you can just click this show available stations. If I zoom in a little bit more, have fewer to show and to load. And this will pop up with a whole bunch of stations that are intended to be or expected to be observations. There should have real like data available, and it's expected to have data that's that parameter that I selected. So wave height data should be available in these. Now I'll click on this one because it's further offshore, might give us some helpful insight. And once I click on it, it does load my data values in this table, so I can confirm, yes, I see wave height here. So I'll go ahead and pick my comparison and move forward with my validation. So we're looking at global GFS wave height, and then click calculate. And it might take a moment while it's thinking, but it's going to generate a few tables and plots for us. We'll get an error statistics table. We'll see a line or a scatter plot that's going to put the observation data on the, I think it's on the x-axis. Oh, here we go. Now that it's loaded, I can confirm. Yes, so the observation data is on the x-axis and then the model data on the y-axis, so we can get a good idea of how that observation is comparing to the model. And then, of course, what's also helpful is having that time series with both of them plotted over time so we can see how closely and where they may have diverged from each other. All right, I think that's it for this insight. So I'm going to move to my last one, which is the surfer's dashboard. And this one is geared more towards recreational users. It is a little bit simpler, but again, it's a really great starting point where anyone who likes to surf could come in here, change the data for the location or the beach that's their favorite spot, as well as add more widgets or more information that's helpful for them. So we do have some real-time observed data. We've got wave height, wind speed, water temperature, and air temperature, along with the valid time there at the bottom. This is a full OceansMap widget. It does look pretty similar to the last one I showed you, but a key difference here is this Activate Hover tooltip. So once I click on that, I can hover over anywhere on my map and it'll just think for a second and it's going to pop up with values at that location with the most recent available data for the data sets. Just needs a minute to think. I will come back to this one as I think it's just taking a moment. But I can open up the legend and show that we are seeing these global GFS winds, which are these streamlines, these animated streamlines on the map. And then there's also wave direction, which you can kind of see faintly, these arrows on the map as well. And wave period and wave height are the color overlays, I believe. If you were editing this map widget, or even if you just wanted to dive into that map a little bit more, you could do that by unlocking the lock icon, clicking into this settings as well, like we did before. And so the OceansMap map widget is actually just created through a permalink, which I've shown you a couple of times how to make. So if you grab that permalink, I'll just cancel and relock this. You could also put it in a new tab and it will open it up in a full map view, which will allow you to really use all of OceansMap's features and functionality. So while I let that load, let me come back here and finish up what we're looking at. So we do have more time series down here as well. We've got some predicted and observed values. We've got wind speed, and then the model value also goes into the future a little bit. We've got wave height, same thing with observed and predictions on the same time series. And then down here, we just have model data sets of wave period and wave direction, and a rose plot showing wave direction and period as well. All right, let me see if this is still loading a moment. That's okay. Oh, it could also be my computer. I think it's being weird today. Well, while that continues, I know that this was all a bit of a whirlwind. I think that's about all the time that I have. I just want to mention a couple quick reminders. Please don't hesitate to use that feedback form if you do have any suggestions or questions after today. And if you are curious about learning more how to use any of these tools, or just kind of if you get in here and you're working on something and you get stuck, Maricoo's actually has some really helpful tutorials on YouTube. So I highly encourage that you check out their YouTube channel, take a look at some of those videos. But if you are also working in here and unable to, or you just, like I said, maybe got stuck on something, have a question, there are these info icons at the top of each table or each tool rather. And once you click on that, you'll get a pop-up window with some really helpful text. The videos themselves are embedded directly into OceansMap, and they give a lot of like really detailed information. Some are just generic introductory level information, but then some will go into like more advanced features like multi-selecting and changing features or settings for multiple widgets at once. So I think I will leave it there. Oh, this is giving me a little bit of trouble, but this is a good, I'll leave it right here just showing you how that map view was able to load. And I could come in here now and even use weather window, add more virtual stations, and update that map back on my dashboard. All right, I will pass it back to Maricus. Thank you.
Thank you very much, Sherry. We have just a few moments if anyone has any questions for Sherry about OceansMap Insights or any feedback on additional insights that might be helpful for them or their organization. Again, feel free to drop that in the chat or to unmute yourself and ask. We have just a couple more minutes for that if anyone has any additional questions. All right. Well, Sherry, I really appreciate your time. You are so knowledgeable on OceansMap and you do such a great job of explaining it to everyone. So thank you very much for taking the time today. And thank you to all of our other speakers. Thank you, Tina. Thank you, Tim. Thank you, Ava. We really appreciate everyone's time and information. And thank you to all of you for attending today and tuning into our webinar. Before we sign off, we just want to remind you that there are some ways to stay connected with Maricus. We do have a newsletter that you can sign up for, as well as we are on social media. This webinar will be posted on YouTube probably tomorrow or Monday for future reference. And I'm going to just drop all of our social media links in the chat. And if anyone has any questions, please feel free to reach out. The best email address is going to be info@maricus.org, and I will drop that in the chat as well. And thank you again, everyone, for your time, and hope everyone has a wonderful rest of your day.